Today we will study how to prove the following identity that is shown. So we will deal with a product. So at first, what we have to note here, they say prove that for all n that belongs to the natural numbers, you will have this. Of course, in this case, they are supposing that the natural numbers, maybe I have to address this. The natural numbers bigger or equal than 1 in this case. It depends on which do you choose to be natural numbers, if they start from 0, if they start from 1. Okay, this is just a small thing that we have to take care. So okay, we will start. So at first I will note the sequence an by the product from I from 1 to n of 1 plus 1 divided by 2i. Okay, so at first you have to know something important. This is an increasing sequence. What does it mean? If you see a by n plus 1 is the product from a equal to 1 to n plus 1 from 1 plus 1 divided to I. Yes. This is equal to the product. This product is product of e1 to n plus 1. I'm sorry, no, this is n only n from 1 plus 1 divided to I, and this is multiplied by 1 to 2 n plus 1. Okay, and this is an, sorry, and this number from here 1 plus 1 divided 2 to the n plus 1. Only this number from here is bigger than 1. So it implies that this is bigger than an. So this is an increasing sequence. Okay, so now it's an increasing sequence. So if this is real for all n that belongs to the natural numbers, then we have that this sequence will be a sequence which is increasing. So we have to show that the limit where n tends to infinity is less than 3. So this problem is changed to finding the value of this product. So if this is the bound, this is the lowest superior bound of this sequence. So we have to find this product. Okay, so from here, let's say that this exists. Call it L. So we will put natural logarithm of L to both sides. So we will get limit where n tends to infinity from the sum from a from 1 to n of the natural logarithm of 1 divided to I. This is the natural logarithm of L. Yes, now we have to check that this limit really exists. How can we do that? We can use, at first let's show that this sum exists, or it is bounded. So we will use this inequality. 1 plus x is less or equal than e to the x. Yep, this is a well-known inequality for x, at least for x bigger or equal than 0, and it's simple to show this is right because we can expand e to the x using the Maclaurin series. X squared divided to factorial plus minus 1 minus x. So this is eliminated and only have x squared divided to factorial plus So and this is of course bigger or equal than 0. So okay, we prove the inequality, this important inequality from here. These are positive numbers, so of course it's possible we can extend even more. Actually, it's possible to extend more the domain of x, but For us it's okay because 1 divided 2 to the I is a positive number for any value of I. Okay, so now we use this inequality from here, and we write natural logarithm of 1 divided 2I, 1 plus, sorry, plus 1 divided 2I. This is less or equal than the sum from a1 to n, of course with the limit. We shouldn't forget the limit. This limit from here. Okay, give me 1 second so I can get some space for our expression from here. Okay, this I have to rewrite some things, no problem. Yes, so okay, we can see from beginning that it will converge. It will converge surely. 1 divided 2I. Okay, we know the value of this sum already. This is 1 divided by 2 divided by 1 divided by 2. This is 1. Okay, so we could find that the natural logarithm of L is equal to is at least this is sorry is bigger or equal than, because we suppose bigger or equal, sorry, we found L, and it means that the natural logarithm of L is less or equal than 1. So we can use the exponential to both sides. It maintains the inequality, so we get that L is less than E, and of course E is less than 3. So what did we find? We find the following. We find that A1 is less than A2 and less than A3. We show actually for any n. So we show for an plus 1, and we could show also that this sequence tends to E. Yes. So we know that the bound of this sequence is E, and of course E is less than 3. So we were able to prove finally that the sequence is less than 3 as expected, but more important, without taking account of all the notation that we introduced, is the fact that we could prove that this product is less than 3 as expected. So okay, today we could see some important properties. At first we could see the meaning of increasing sequence. Also we could use one interesting inequality. Actually, about inequality, if we draw this inequality, it has like this, and this function E1 plus x has this form. Yep. So okay, at least graphically we can see why it is bigger or equal, and also that we could extend the domain of the inequality not only to any value of x bigger or equal than 0, but also for all the real numbers. But okay, in this case it was not so important after all, because we only require x to be bigger or equal than 0. Also we could see how to transform using that property. We could see, and using that property and transforming the product in a sum, we could see how to bound this sum with a logarithm inside, because it was complicated at the beginning. After that we could see one geometric series, and the geometric series was immediately, we didn't take too much. We just use this property. Maybe I will summarize the properties used in the video in this few minutes. 1 minus 1. Of course, x must be less than 1. Okay, the absolute value. Okay, using that property, you could see 1 divided 2 divided by 1 minus 1 divided by 2. Make some algebra. This is 1. Then coming back again, you know, the exponential function is an increasing function. E to the x is an increasing function. So, okay, if x is less than y, so e to the x is less than e to the y. And after that, okay, just comparing, because e to the 1 power is just e, and e is 2.71. Okay, you know it already very well, and this is less than 3. Okay, that is all. Which could be like more for problems, like can we improve this bound? Okay, we actually 3 was a not so strict bound. You could see even we could expand 1 at first degree and we could obtain this bound. So one question will be like, what is how can we obtain better bounds instead of 3? Okay, e can be a better bound too, but can we find even better bounds? Okay, this is one question that we can make for further investigation. And okay, which other problems can we solve with this property? Okay, it's something too that we can check in other videos. So okay, this is all for today. Thank you so much for your attention. Please look at the other videos. We will be updating more content in these days of quarantine. And thank you so much for watching. Have a good day to everybody. Please stay safe.